Download this code from codegive.com, link in the description below. Python socket handling client disconnect, a deep dive, with Stack Overflow discussion. Handling client disconnect ions gracefully in Python socket programming is crucial for building robust and reliable network applications. Unexpected disconnect ions can lead to errors, resource leaks, and a poor user experience. This tutorial will explore various disconnection scenarios, best practices for detecting and handling them, and connect them to common questions and solutions you might find on Stack Overflow. We'll cover different techniques and provide comprehensive code examples. 1. Understanding disconnect ions. A client disconnection can occur for various reasons. Asterisk client initiated close asterisk the client deliberately closes the connection, example user quits the application. Asterisk network issues asterisk temporary network outages, firewall rules, or routing problems can interrupt the connection. Asterisk client crash asterisk the client application might crash unexpectedly, terminating the connection without a proper close. Asterisk server shutdown asterisk the server itself might be restarting or shutting down, abruptly closing client connections. Asterisk idle timeout asterisk the server might intentionally close connections that have been idle for a prolonged period to conserve resources. 2. The problem, blocking reqv and send. The primary challenge arises from the blocking nature of the reqv and send methods in Python sockets. When a client disconnects without properly closing the connection, a reqv call on the server can remain blocked indefinitely, waiting for data that will never arrive. Similarly, a send call to a disconnected client can trigger exceptions. 3. Detecting disconnect ions. Here are several ways to detect client disconnect ions in Python. Asterisk reqv, returning an empty string asterisk this is the most reliable indicator of a clean client disconnect. When a client gracefully closes the connection, using socket.close, the reqv method on the server will return an empty string, when there's no more data to receive. Asterisk reqv, raising an exception, connection reset error, broken pipe error, connection aborted error. These exceptions signal various types of connection errors that often indicate a client disconnection. Connection reset error typically occurs when the client forcibly closes the connection or the connection is unexpectedly interrupted. Broken pipe error usually arises when you try to send data to a socket that has already been closed by the client. Connection aborted error typically occurs when a connection attempt was aborted by the host. It's important to handle these exceptions gracefully. Asterisk select, /poll, for readability asterisk the select or poll modules allow you to monitor multiple sockets for readability, meaning data is available to be read. If a socket is readable but reqv returns an empty string or raises an exception, it indicates a disconnection. These approaches help in non-blocking or asynchronous scenarios. Asterisk heartbeat mechanism, keep alive implement a heartbeat mechanism where the client periodically sends a small ping message to the server, and the server expects to receive these pings within a certain time frame. If the server doesn't receive a heartbeat within the expected time, it assumes the client is disconnected. This is particularly useful for detecting disconnect ions caused by network outages or idle clients. 4. Code example, handling client disconnects with exceptions and empty string checks. Explanation asterisk. 1 handle underscore client, con, address, function asterisk. Asterisk this function manages the communication with a single client. Asterisk it enters a while true loop to continuously receive data from the client. Asterisk data equals con.reqv, 1024, receives up to 1024 bytes of data from the client. Asterisk if not data, this is the crucial check. If reqv returns an empty string, it means the client has gracefully closed the connection. The loop breaks, and the code proceeds to close the socket. *try, except block, catches potential exceptions that can occur during communication. *connection reset error, broken pipe error, connection aborted error, these exceptions are caught to handle abrupt disconnect ions. *con.sendle, data, sends the received data back to the client, echo server. *finally block, ensures that con.close, is always called, even if exceptions occur. This is essential for releasing resources and preventing socket leaks. *start_server, function *. Creates a TCP socket using socket.socket, socket.af_inet, socket.sock_stream. *s.set sockopt, socket.sol_socket, socket.so_reuse 1. This allows you to quickly restart the server without waiting for the socket to be released by the operating system. This is helpful during development and testing. *s.bind, host, port, binds the socket to the specified host and port. *s.listen, starts listening for incoming connections. *con, address equals s.accept, accepts an incoming connection. This is a blocking call, it waits until a client connects. Creates a new thread for each client connection to handle multiple clients concurrently using threading.thread. *client_thread.daemon equals true, this allows the server to exit even if the client threads are still running. This is important for clean shutdown. *client_thread.start, starts the thread. How to test the code *. 1. Run the server script. 2. Create a simple client script, or use telnet, to connect to the server. Here's a basic client example. 3. Test graceful disconnection *. Run the client, let it send some data, and then close the client program normally. Observe the server output, you should see the client disconnected gracefully message. 4. Test abrupt disconnection *. Run the client, let it send some data, and then abruptly terminate the client program, example by killing the process. Observe the server output, you should see one of the error messages, example client disconnected abruptly, connection reset error. 5. Test sending data to a closed connection *. After a client disconnects, either gracefully or abruptly, try to send more data to that client connection from the server. You should see a broken pipe error on the server. 5. Heartbeat mechanism, keep alive. This approach is vital for detecting disconnect ions due to network problems or client inactivity, which are not immediately signaled by RECV. Client-side heartbeat *. Explanation *. 1. Client handler class, server. *last_heartbeat, stores the timestamp of the last received heartbeat from the client. *run, the main thread for handling the client. Receives data and checks if it's a heartbeat message. If so, updates last_heartbeat. Otherwise, processes the message as usual. *check_timeout, called periodically by the server to check if a client has timed out. If time.time, self.last_heartbeat timeout, it considers the client disconnected, closes the socket, and sets self.is_connected equals false to break the loop. The client is removed from the global clients list after disconnection or timeout to prevent memory leaks and further processing attempts. *con.shutdown, socket.shut_rdwr, prevents further sending or receiving on the socket, making the socket unusable, preventing resource leaks. 2. Start_server, function, server. Asterisk maintains a list of active clients. Asterisk accepts connections and creates a client handler thread for each. Asterisk the main loop now also iterates through the list of clients and calls client.check_timeout for each client. This is crucial for detecting timeouts. It is important to iterate through a copy of the client's list, using list clients, to avoid errors if a client disconnects and removes itself from the list during iteration. Also ensures that only live threads are checked using client.is_alive. Asterisk handles keyboard interrupt for clean server shutdown. Asterisk ensures all client sockets are closed on server shutdown to prevent resource leaks. 3 Client heartbeat asterisk. Asterisk sends heartbeat messages to the server every heartbeat_interval seconds. Asterisk the server expects to receive these heartbeats and updates the last_heartbeat timestamp accordingly. Key improvements in the heartbeat example asterisk. Asterisk timeout detection asterisk explicitly checks for timeouts based on the timeout value. Asterisk client list management asterisk keeps track of active clients and removes them upon disconnection or timeout to prevent issues. Asterisk clean shutdown asterisk handles keyboard interrupt for server shutdown and closes all client sockets to avoid resource leaks. Asterisk error handling asterisk includes more robust error handling, especially when closing sockets that might already be closed. Asterisk con.shutdown, asterisk calls con.shutdown, socket.shut_rdwr, before closing the socket to signal to the other end that the connection is closing, potentially preventing issues like delayed socket release. Asterisk thread safety asterisk removes client thread from the list of active clients only when the client is disconnected, has timed out or has exited to avoid race conditions. Asterisk iteration over a copy of the client list, iterates through a copy of the client's list to avoid runtime error, set changed size during iteration errors when a client disconnects and removes itself during the timeout check. Asterisk heartbeat interval is a variable, makes it easy to configure the heartbeat interval. Asterisk randomly sends heartbeats or messages, simulates a more realistic scenario in which the client isn't constantly sending heartbeats. 6. Stack Overflow and common questions asterisk asterisk. Here are some common questions related to Python socket disconnects you'll find on Stack Overflow, and how they relate to the concepts discussed above. Asterisk Python socket reqv, blocking forever after client disconnect. Asterisk relates to asterisk the blocking nature of reqv, and the need to check for an empty string return. Asterisk solution asterisk the code examples above directly address this by checking if not data after the reqv call. Asterisk how to detect a client disconnect in Python socket programming. Asterisk relates to asterisk the different methods for detecting disconnect ions, empty string, exceptions, select/poll, heartbeats. Asterisk solution asterisk the tutorial covers all these methods and provides code examples for the most common approaches, empty string and exceptions. Asterisk broken pipe error, error 32 broken pipe when sending data to a client in Python socket. Asterisk relates to asterisk the broken pipe error exception that occurs when trying to send to a closed socket. Asterisk solution asterisk the code includes try, except broken pipe error to handle this exception gracefully. Also, using heartbeats can proactively detect disconnected clients before attempting to send data. Asterisk connection reset error, Winer 10054 an existing connection was forcibly closed by the remote host. Asterisk relates to asterisk the connection reset error exception for abrupt client disconnect ions. Asterisk solution asterisk the code includes try, except connection reset error to handle this exception. Asterisk Python socket server, handling multiple clients with threads. Asterisk relates to asterisk using threads to handle multiple client connections concurrently. Solution The code uses threading.thread to create a separate thread for each client, allowing the server to handle multiple clients simultaneously. Also includes client_thread.daemon equals true for clean server exit. How to prevent socket leaks in Python. Relates to the importance of closing sockets properly in a finally block. Solution The code always closes the socket using con.close, in the finally block, ensuring that the socket is released even if exceptions occur. The heartbeat example also uses con.shutdown, before closing. Python socket timeout. Relates to detecting inactive clients and closing their connections. Solution The heartbeat mechanism addresses this directly by monitoring the last time a heartbeat was received and closing connections that have timed out. 7. Important considerations Buffering when sending data, be aware of buffering. Send, might not send all the data at once. Use sendle, to ensure that all data is sent. Non-blocking sockets for more complex scenarios, especially with many concurrent connections, consider using non-blocking sockets and the select or poll modules. These allow you to monitor multiple sockets for readability and writability without blocking. Libraries like Asyncio are also excellent for asynchronous network programming. Error logging implement robust error logging to help diagnose and troubleshoot disconnection issues. Security when dealing with network communication, always consider security implications. Use encryption, example TLS/SSL, to protect data transmitted over the network. Validate input data to prevent vulnerabilities. Operating system limits be aware of operating system limits on the number of open sockets. You may need to adjust these limits for high concurrency servers. Linux systems have ulimit settings. In summary, handling client disconnections is an essential part of building reliable Python socket applications. By understanding the different disconnection scenarios, using appropriate detection techniques, empty string checks, exception handling, heartbeat mechanisms, and implementing proper resource cleanup, you can create robust servers that gracefully handle unexpected disconnections and maintain a stable and responsive user experience. The provided code examples and Stack Overflow references should give you a solid foundation for handling this common challenge in network programming. Remember to adapt these techniques to the specific requirements of your application.